We're going to do a hopefully fun challenge here, which is I wanted to see if we could get you up and running with a deep learning image classifier, basically an AI system that will classify pet breeds, dog and cat breeds, from a given photo and tell you what breed of cat or dog it is. So what we'll be using today is the Oxford Pets dataset. We're going to use PyTorch. We're going to use FastAI. Basically what we're doing is taking the FastAI lesson 1 and trying to compress it down from, it's about 2 hours normally. I want to compress it down to hopefully under 20 minutes here, but walk you from beginning to end, loading up the system, training it, getting results, and basically letting you see firsthand kind of the power of AI at work. So we've got some examples here of all the different breeds that we'll be working with, so a variety in terms of image statistics. We've got 5,000 different dog photos, 2,300 cat photos, and 7,300 total photos. So that being said, let's get going. First thing that I found really hard when I started deep learning a while ago was just getting a system configured. There's a lot of different libraries and so forth you have to install, and I have to make sure they're compatible and blah, blah, blah. But things are a lot easier now. I'm using salamander.ai, and if you go there, you can make an account to run this tutorial, or just to follow along in the video basically, and run your own AI or build your own AI system. Probably take you about 35 cents, 50 cents, something like that. Now I've actually got a server spun up. This one here. It's online. It's just to save a little bit of time. Well, it can take a minute, 2 minutes to load. But what you would want to do is go here, make an account. It will require a credit card because they do charge 35 cents to $1.50-ish an hour, depending on which GPU you use. And you do want to have a GPU that's kind of the parallel processing that does the matrix multiplication that's needed to do deep learning. So design another server. It'll give you a name, but you can say my new server. Key point, you want PyTorch 1.2, FastAI, and the V3 course, because we're going to do the lesson 1. This is just the pre-built libraries that will let you get up and running quickly. And as I said, I've already got a server running, but once you have this specified, should let you compress. Okay, yeah. So anyway, now I'm loading up another server. But anyway, you would jump in here. You'll wait for your Jupyter Notebook to load up. I'm gonna let that one spin up because that'll take some time. This is the one we're going to use here. That would click on Jupyter Notebook. That gets you in. This is where you'll be at. You want to go into course, in this case V3. One thing that was a little bit tricky is where are your notebooks you're going to work with. Notebook is sort of the interactive working environment that we do all of the FastAI and deep learning work in, but it's under NBS for notebooks. In this case, DL1, I guess, represents class 1 and lesson 1 pets. Now, I actually already have that running right here, so we're going to jump right in again to save time because there's another minute or so for it to load up. If you haven't seen a Jupyter Notebook before, it's basically an interactive command line, if you will, but you can have prose and media between all these different cells telling you what's going on. This is the gray cells or the actual code itself, and we'll just walk through line by line or cell by cell, and I'll show you a quick summary of what's going on, and we will spin up the deep learning system. So one key point to execute a cell or have it run the code within, the keyboard shortcut is Shift Return or Shift Enter, and that will actually execute it. So I've already run these two here. Actually, I need to change one thing. This one here is just telling it to load things, if you change things, to load them in place, and matplotlib to put where to put the plots. Key libraries we'll use here is FastAI Vision, FastAI Metrics, and I want to add accuracy, which is just the inverse of the error rate. I have added two things. It's not in the course, but I find extremely handy. You do want to verify what version you are running. That's a simple command here. So we've got FastAI 1.057 and PyTorch 1.2. I'm just rerunning there. So getting into the basic deep learning parameters, one of the key hyperparameters was what they call batch size, and that is how many images at a time are you going to show to the AI system to help it train. And that's basically constrained by how big is your GPU, more specifically how much memory does the GPU have. Depending on the size of the images, it can it varies whether it's a GPU or a TPU or so forth, but then it is by default we're going to try 64 here. That's why there's this comment for batch size equals 16. Maybe you can try 32, but the net is you can sometimes get a CUDA out of memory error, which basically means you're trying to load up too many images onto the GPU at once, so you reduce that. So batch size 64 I believe will work on this system. although we'll find out in a minute. Next cell of importance is here. This is basically, we need this data set. That's the one I showed you the images of earlier. And credit to these kind folks for making the data set. This is just some stuff to make sure that we have some images showing in the proper directory. I'm going to set some path to the images there. Check that we do have image files. And we are going to use regular expressions. And the reason for that is what we have under, if you look at this one here, it is images / St. Bernard 188. But in this particular case, the data set has the answer or the label built into the file name. So in other words, just by seeing this, we can say, hey, this is an image of a St. Bernard. So the correct answer, when the AI looks at this, it should flag it as a St. Bernard. But we need to pull that information out and have the answers ready to present to the AI or deep learning neural network at training time. And we'll use a regular expression for that. So this command here, we're going to bunch our data. That's all these images. We're going to get the file names. We are going to do some transforms. I don't think, offhand, I don't remember what the basic ones are for FastAI, but there's just some quick transforms that may randomly flip and may randomly crop a few things. But the key ones here, we've got size 224, batch size is that 64 that I showed you earlier. And normalize just means we need to put them all on the same relative scale to make it easy to train. This next command here is we're going to take a batch, and that's a subset of the 64 images and just see what are we looking at exactly. This is mostly a good check to make sure that your data is loading properly for the data bunch and that you're going to be feeding the right information to the deep learning system. Okay, so here we go. You can see some of the random results in terms of images. These are not the actual sizes that will be shown. It's rescaled, but just so you can take a quick check. So we got Siamese cat, Persian cat, Egyptian Mao, Beagle, Pitbull, Beagle, the Beagle, English Setter, Sam Whiteley, and Burger, etc. So next thing we want to check, do we have the right labels? And this is what that data.c will do. In this case, you can see these are all, 37 as we expect. So it looks like everything is ready to go. We need to make an actual neural network. I'm going to change this to add that in. It's just the inverse of error rate, but I just find it easier to look at. And this is the main command here. We're going to make a neural network architecture called ResNet34. I'm not going to get too many details, so I'm just trying to do this fast, but that is the core structure that basically takes an incoming image, loops through a whole series of convolutions, and basically outputs the answer that it thinks what it is. So we'll get that loaded up, and it does not like, oops. Does not like that. So let me pause the model, see what's going on, and I'll be right back. All right, we're back. I just wanted it to be in a vector form to accept that. So I believe we have this loaded. Hit that again. Yep, looks good. Learn.model is just going to give you a summary, and this is actually going to give you a chance to see what exactly you have loaded up here. Again, I'm not going to go into too many details of what all the breakdown is, but as I mentioned, it uses convolutions, so that's your conv2D. And it's just a whole series of repetitive convolutions, plus ReLU is your nonlinear activation. You can basically think of deep learning as matrix multiplication or kind of linear algebra with nonlinear functions stuck in between to go from straight line to curvy lines and produce a output that matches what you're after. So there's our quick function. This is I would not use dropout for reference, but anyway, it's there. So let's get into training. What we've got here, this fit one cycle is one way to structure a training cycle, and learn, of course, is the actual neural network. So what we're basically saying here is run through all the data, all the images that we're going to show you, learn from that, and then we'll test you on it at the end of each cycle, called an epoch, and we're going to do it 4 times. So let's jump right into training here. Let's see how long this will take. A few seconds to load up. And we're underway. So we're actually training a neural network. I'm guessing we're 6 minutes in, I'm not sure. But what you're seeing here is we've got 92 total epochs to run through the entire data set. And this is giving you a time estimation of how long it's going to take to complete. So it looks like it can take about a minute to loop through each epoch. So I guess we're going to take about 4 minutes here to to actually let that run. So while that's running, I think we'll go ahead and skim down just a little bit further and come, well, let's see what happens on the first epoch here. So 86%. So we're just about done. So that's the training phase. And now we're going to run into the testing or validation phase. And that's where it's going to basically give it a bunch of pictures and say, what's your prediction? It's going to compare that prediction with the correct answer and give you a percentage result of how accurate it was or was not. So on our first epoch here, we've got 88% accuracy. So not bad at all. Now, I should mention that this ResNet is what they call a pre-trained network. In other words, it's not necessarily seen images of cats and dogs before, but it has seen images from ImageNet, which is basically a very broad, it's 1.2, 1.4 million image data set. And it's kind of like saying, hey, you're going to have an athlete who's ready, and then you're going to train them for the specific event you want to. And that's probably going to get you further than if you just take somebody that's never trained a day in their life and then try to train them to do something. So that's the concept called pre-trained network, and that is what let it speed up the training, relatively speaking, to if we just started with the basic native network. So we're just about heading for the second epoch here. And validation. %. So we're getting up there. While that's running, and let me just show you a few more, but whatever time we took here, 6 minutes, we're up and running with an actual AI or neural network deep learning system. This, of course, will let you save. FastAI has some different functionality that will let you look at kind of how where things are not working right. I don't want to load this up yet since it's not done. We'll get into that, but basically, as you can see, this has already been run on previously. And it's basically showing you, in this case, the prediction, what it actually was, what the loss was, but more importantly, what was the probability. So was it confident or not confident about the answer? And what it's actually doing here is taking the ones that had the biggest loss, in other words, the biggest miss, where it was wrong the most, and just a way to visualize, how it's doing, basically. They also plot what's called the confusion matrix, and that can you want to see, of course, a nice diagonal line here. And that's basically showing you what it actually was, what it predicted it was. And then, for example, like you can see down here, it's having a problem on American Pit Bull versus Staffordshire Bull Terrier, which actually are two breeds that look very, very similar. So it's not surprising, but by looking at this kind of an overview, you get to see how it's performing, where it's weak, where it's strong, and give you some good feedback on it. Let's jump up and see if we're done here. Almost. One more, but basically you see we've jumped from 88%, 91%, 92%. Hopefully we'll hit 93, 94 here on the finish, and then we can jump into these cells. But congratulations, you are up and running and training a neural network or deep learning AI system already. So that's one of the beautiful aspects of FastAI is it gives you a lot of pre-built modules, so you can kind of focus more on the task at hand and not on a lot of the grunt work in terms of like just organizing that data set and the few lines up above. There's a lot of code going on underneath that would take you some time to do that by hand. So it looks like we ended up at 93%. That's just to save out the model if you want to. Now let's get into see how we actually did with our specific model and not the one that was run for the course. Okay, so it's loading up the interpreter. True just means it was successful. And what do we have? Well, not surprising. Beagle, it's a little bit surprising, actually. But anyway, it's just going to show you the top losses in terms of where it had the biggest miss. Looks like it's confused on Beagle quite a bit on these first two. Yeah, another Beagle miss there. And of course here, Bull Terrier versus American Bulldog. It's another tricky one. And also another Pit Bull versus American Bulldog. So let's load up. This is just documentation for reference. Pound will comment it out. Let's see what our results are for our specific model. Okay, Burman versus Ragdoll, I think is what that's looping to, or Russian Blue, I'm not sure. So we've got a few, here's Ragdoll and Burman. So this is where it's got some of the biggest misses. These outliers here, we've got 5 and it's highlighted. Down here we've got a 7, for example. Again, it's not surprising. because even for a person, I think it's hard. Staffordshire Bull Terrier versus American Pit Bull, kind of tricky, but as you can see, we've got a good, nice diagonal line showing good congruity. So continuing there, most confused is a way to pull up again in a more text form where it's missing the most as opposed to the visual form above. And no surprise, the biggest one was that Pit Bull versus Bull Terrier, Burman versus Siamese, Ragdoll versus Burman, the different cat breeds that look kind of similar. So all in all, not bad, but we can do better, and that's what this will be about. So I have a concept. When we were training up above earlier, by default, it was only training the last few layers, which you can kind of think of, they call it the head. And there's some reasons for that, but we're going to go ahead and unfreeze the entire setup. We're not going to run this because if you just jump in with that same learning rate, it will blow it up, which is why they're reloading here. But we have in FastAI a learning rate finder. So learning rate finder is how quickly or slowly should you make adjustments to the weights or parameters that are within the neural network to train it, basically. And it's kind of a trade-off. Of course, you want to do it fast because you don't want to waste a lot of time and a lot of computation. But on the other hand, if you go fast, you can skip right past where the proper answer is and bounce back and forth and never actually what they call converge to the correct answer. So this is one way. This is more the FastAI way, basically, of trying to find an actual learning rate recommendation on here. So I've got that loaded or run. We'll load up the plot. I'm not going to get it too deeply, but basically you want to pick, you've got this downward slope. When it's shooting up like this, your gradient's going to explode, so you don't want that. So we would end up picking somewhere. I wouldn't go 4. Now he's got this 24. Let's back. 24 is actually the bottom. We don't want to be there. We want to be about 10x back. So let's cut back to 5 roughly. We'll take this slope right here. So a little bit of a change from the lesson there. And we're just going to do 2 epochs. And this slice is basically going to give it a spread. So the beginning of the neural network is going to get a lower learning rate, and the middle will get a medium learning rate, and the head, so to speak, or classifier proper, will get a more aggressive learning rate. So we'll go 2 more epochs here. This is taking a little more time because at this point we're adjusting the entire neural network and not just the last few layers like we were doing above. That was one of the reasons it was faster. So hopefully 20, looks like it's going to take about a minute each here. So while that's running, let's just jump down. Probably won't bother for this part, for this video, but it's going in here, and you can take a bigger model, which will give you even more accuracy because it has more computational power and therefore potentially more accuracy. It's not always the case. It can get harder to train, so there's some trade-offs. But let's just see how we did here with our slight adjustment to this learning rate. And I think that's going to conclude the video. So let's see where we got. Not a whole lot of improvement. 90, again, 92.8. See if we can get a little higher on this last one. But in summary, that's pretty much it. So obviously you can get a lot more complex if you go deeper under the covers in terms of the architecture and the optimizer you're using and how do you establish the proper learning rates and et cetera, et cetera, et cetera. But the gist of it is, and my point on this was I just want to try to compress the very quick details from the FastAI course. I would highly recommend, if you're interested, obviously watch the full course with all the details, but I wanted to give you the opportunity to just see a deep learning system in action, built not completely from scratch because we have a lot of pre-built components, but basically spun up and trained on a new data set that it hasn't seen before. And as you can see, we can get pretty good accuracy pretty darn fast. So let's see where we ended up. Doing the validation here. 93%, so not bad. So that's all for this video. Again, I want to keep it short, sweet, and congratulations, you actually have trained your first AI deep learning system.